This is lesson number 10. We now get to create our own sinusoidal graph based on data, which is kind of fun. It should tell you whether you're building a sine or a cosine graph. So here we're building a sine graph, and we have to provide the A, B, and D descriptors, which means we've got to try to figure out a little bit of information. We've got a nail that's caught in a tire. And it's rotating 10 revolutions per minute. So if you think about what the nail's doing, the nail is completing one cycle in how many seconds? That's actually what I need to record. I need to record how long the period is. Some interesting information. It says the tire or the nail is at the ground at 4.5 seconds. So this being the ground, this is 4.5 seconds. And we want to get some understanding of period. I did 10 revolutions per minute. That means in 1 minute, I did 10 revolutions. Whoops. In 1 minute, I did 10 revolutions. How long does it take me to do one revolution? Well, first of all, I need to get to 60 seconds. So 60 seconds does 10 revolutions. 60 divided by 10 means it takes 6 seconds to do one revolution, which is going to help me find the end of my graph period. That's 6 seconds. So period is equal to 6 seconds. And remember, the formula for period is 2 pi over b. Well, I just figured out what period is. So now I can get my b value. 2 pi divided by 6 is equal to b, which means b is pi over 3. And again, here note we're working with radians, not degrees. So that should always be understood. The diameter of the tire was 50 centimeters. I see that physically here, 50 centimeters. It means I have an understanding of my amplitude. There's 25 centimeters above the line and 25 centimeters below the line, and that's my A value. My A value is 25. And now my D value. Where in the world am I? I should be down at the x-axis and go up 1 and down 1, but I've actually been transported up to the 20 watt meter mark. So yes, the D value would in fact be 25. So my equation becomes the height of the nail at any time t is equal to 25 sine my b value, which was pi over 3 times t. Make sure I include that in brackets, plus my vertical displacement, which is 25. And now I can use that equation to answer the question, how far to the nearest tenth of a centimeter is the nail above the ground after 6.5 seconds? So maybe being a little careful with how you enter your t in. I try to worry about my brackets, but at 6.5 centimeters, the height of the nail is 37.5 centimeters. Sorry, that's for that question there. Let's turn the page. We've got a Ferris wheel to model. So they haven't even built me the graph here, which is a little bit awkward. So I've got to create a graph, or at least a sketch of a graph. You could graph in your calculator if you're accustomed to that. You might know that from physics, but I'm going to graph using pencil and paper. At time 0, I'm at 4 meters above the ground. At time equals 2.25 meters, I'm 42 meters above the ground. At 4.5 meters, I'm 80 meters above the ground. At 6.75 meters, I'm 42 meters above the ground. And at 9 meters, I've returned back to the ground. So I see a general shape, that might make me think about a cosine graph. It could be a sine graph, but I've been asked to model that using a cosine graph. So we've got to take a look at some of those same features. First of all, where should the cosine graph have started? The cosine graph should have started way over towards the left. How much has it shifted over? You'll notice that your max height is here at 4.5 minutes. We have a shift in the x-axis of 4.5 minutes. That's my c-value. I have a horizontal phase shift of 4.5 minutes, and that's in the direction of right. My amplitude is way off of 1, so I've got to figure out what those distances are. Remember, we want to find out the difference by going 80 minus, so the max height minus the minimum height, and then split that over 2. 80 minus 4 is 76, divide by 2 is 38. What am I going to do with that? So the 38 helps give me my amplitude. My amplitude is 38. That means I have to go 38 up and 38 down. So 80 minus 38 will be the location of that horizontal line that cuts the graph in half. So at 42, I've got an amplitude of 38 here and an amplitude of 38 there. That gives me my D value. My D value gives me that vertical shift that goes up 42. So I've got my A value, I've got my B value. Oh, I don't have my B value. I have A and I have D. And I have my horizontal phase shift, which will lead me to D. I need my period. How long does it take to do one cycle? That's the definition of period. So period, you can see by the data that it took a total of 9 minutes to complete a rotation to come back to ground level. So 2 pi divided by b is equal to 9. That means that 2 pi over 9 is equal to my b value. Now I can create the equation, making sure I have my signs correct, make sure I can see everything. So amplitude was 38 and that was positive. So height at any time t is equal to 38 times the cosine of my b value, which is hanging out over on the left there, 2 pi over 9. Then I need my brackets, my horizontal phase shift. I moved left, so that's t minus 4.5. And then to that, I add 42. So again, be careful how you enter it into your calculator, but plug in 5 minutes into the equation. I'm using my table on my calculator, and I get 77.708 meters. And to the nearest meter, that's 78 meters high. After how many seconds? How many seconds after the wheel starts rotating does the cart first reach 10 meters from the ground? Again, this is a nice application of using y2 to be y2 equals 10. Plug that into your y2, see when that line first hits the 10-meter mark. So I had to figure out my windows. My window on the X had to go from 0 to 9, and my window on the Y I actually went from 0 to 90. And now I found that point of intersection, which I now have lost. One moment, please. So my calculator, remember, is going to give it to me in minutes, and I need it to the nearest second. So 0.8159 of a minute is 0.8159 multiplied by 60 to get me to 48.9 seconds to the nearest second. That's 49 seconds. All right, so that does it for our lessons on trigonometry. Lots of areas to work on, ladies and gentlemen. Hopefully today and Monday we get a good opportunity to finish up the work, try the practice test, get questions answered. Please please make use of your time. Use your time on the weekend to help you prepare for the test. Thank you.